How can sunlight make ordinary asteroids dangerous? Join the 3-to-1 science team as they explore the Yarkovsky Effect. On a pleasant day in the Cretaceous, about 65 million years ago, a 10-kilometer asteroid collided with the Earth and wiped out most of the life on its surface, including the dinosaurs. More recently, on February 15, 2013, a much smaller asteroid exploded in the atmosphere over the city of Chelyabinsk, Russia, creating a shockwave that damaged buildings and injured over 1,500 people. Despite these dire scenarios, most asteroids aren't dangerous at all. In fact, out of 500,000 known asteroids, only about 1,000 are labeled as potentially hazardous. We're not sure yet whether some of these potentially hazardous asteroids will hit Earth or not, and that's due in part to the tiny force of ordinary sunlight on asteroids, through a process known as the Yarkovsky Effect, named for Ivan Yarkovsky, a civil engineer who worked in Russia. Here's how the effect works. Ordinary sunlight can exert a force on an asteroid. This is because sunlight is made up of photons, which carry momentum and can push on things. When the photons reach the asteroid, they can be reflected, bouncing off the surface, or they can be absorbed, warming up the surface. If the photons are absorbed, a little later the surface will radiate more photons in the form of heat. An example of absorption and radiation happens on an asphalt road throughout a 24-hour day. During the day, the asphalt warms up as it absorbs sunshine. Then, at night, the surface radiates that warmth as it cools. Just like the Earth, asteroids are spinning as they orbit the Sun, so they have a day and night cycle too. Because of this rotation, the warmest part of an asteroid isn't the spot right in line with the Sun, it's slightly to the side. As the photons radiate from this warm spot, they give the asteroid a little kick, similar to the recoil force on a firing cannon. This recoil force can slow an asteroid down or speed it up, like a car when the driver pushes the gas or brake pedals. If the asteroid is spinning such that the warmest spot is slightly in front, the recoil force will be backwards, and the asteroid will slow down a bit, like a car hitting the brakes. But if the asteroid is spinning the other way, the warmest spot will be slightly behind, and the recoil force will give the asteroid a push forward in its orbit, like a car hitting the gas. These tiny forces can change the asteroid's orbit. If the asteroid speeds up, the orbit will expand. If it slows down, the orbit will shrink. The Yarkovsky effect is really small, but asteroids spend millions and even billions of years in the Sun, which gives them plenty of time to change their orbits, possibly moving them into or out of Earth's way. In light of this, NASA is sending the OSIRIS-REx spacecraft to visit a potentially hazardous asteroid named Bennu. OSIRIS-REx will precisely measure the influence of the Yarkovsky effect on Bennu's orbit, to determine whether it will intersect the Earth's orbit in about 200 years. You can learn more about the OSIRIS-REx mission and Bennu by clicking on the links. This video is an OSIRIS-REx production. OSIRIS-REx is a partnership of the University of Arizona, NASA Goddard Space Flight Center, and Lockheed Martin.